Are we live yet? It looks like so. Okay. Hello. Hello and welcome to another episode of Reasonable Coding. My name is Leandro, and today we will be building GraphQL testing server. Now I'll make this a little bigger, and let's announce that we are live. Okay. Welcome to the new layer here. Going live now. Link. Cool. Code can be found in. Okay. So before we actually share some links around, let's check two things. First, if the sound quality is good, and second, let's create a repo name. So I'll check over here and see if we got any messages. If anyone is already live streaming this. We got 0 people live. Incredible, amazing. Might take a minute. I will edit this video later on. Not 0, amazing. Okay, we have 1. Fernando is live. What do you think of the new sound setup? Can you hear me? Great. Real good. I went full in and I'm using a microphone that I use to record my singing voice, my beautiful singing voice. So I have a Duet, which is external audio interface by Apogee that I've been using for the last 5 years to do recordings of music, mostly acoustic stuff. And I am using a Shure SM7B, which is it must be the most expensive piece of equipment that I own. It's a really, really nice condenser microphone that things like, for example, Michael Jackson's Thriller were recorded with. It's a top-notch microphone. It's really good for recording things. I just happen to have it for completely different reasons. I didn't actually buy it for the stream. But I figured I might as well use it. And last thing, let's do it. Going live now, we will be blah blah blah. Okay, so I guess I just put another tweet here. Yes. Yikes. It's the high quality of my voice that now fills in your stream, I guess. Anyways, going live now. We will be building. Is that how I normally write things? This card. This should be fairly straightforward. Okay. We'll be building. There you go. We can just copy paste that. Add the new tweet over there. We'll be building GraphQL test server tool with RC015. Come and join and retweet for reach, and the link to the event should be this one. Okie doke. There you go. I think this should be all. Tweet sent. If you are on Twitter and by any chance you get pinged by that, do please retweet so that more people can get to know this. I realize it's a little bit on the nose, both to ask and also to tweet. But hey, it's the first day of the year and none of us were as ready as we wanted to be for it. So here we are. Yes, going back to the stream, welcome. I will show the badge again because it's nice. Welcome to Reasonable Coding. Today we'll be building a GraphQL testing tool as described in the event. This GraphQL testing server, right, will encompass some of the tools that we've been using in the past. It will be a command line interface. It will it will be a GraphQL server that is served over HTTP and so on. But the idea is to encapsulate something that can generate random values that match your schema. So you can run it and you can say, this is my schema, and then you get this GraphQL server for free that has test data, has completely random values. So then you can run tests against this server. It's more of an emulator. If you've ever worked with Google Cloud platform emulators, they have all the services such as, there you go. For example, a PubSub service, which is pretty much the same thing as Amazon's offering for it is. But they let you run emulators locally. Here we have, for example, Bigtable. These are databases, right? And then you have PubSub emulator, which is a very, very small version of the service. It has the same interface, but it works in memory, so you can run your end-to-end tests against it, and it works great. I mean, it has its issues, it's beta software, and it changes all the time, but it's better than having to, spin up some machines and test it against the actual PubSub, because the setup for that is much more expensive in terms of time and maintenance and so on. It also depends how much you test. It might actually cost a lot of money. I don't know what your use case is. But for what we want to do here, right, we want to have this server, right, spin up on some port with some schema. It should be fairly flexible. It should be able to read the schema and essentially build a GraphQL server. It should be fast. For every query, it should respond in a reasonable amount of time. We will define what is reasonable or not during the live stream. And I actually don't have that much time. I don't have 7 or 8 hours to spend on this, even though I would love to. So we will just get the project started, which means we will scope down exactly what we need, so we have something that does the job, and then we'll publish it. It will be on GitHub, and then I'll keep working on it. It's something that, for example, for work, I would very much like to have, but I haven't found time at work to do it, and you know how priorities work. Anyways, this will be all. I'll read this. We will build a server that we can use to very quickly test our clients against all sorts of data returned by this API, and quickly identify what paths of code break. It might be that you hard code some responses for your GraphQL service, and then because the service didn't actually respond always like that, then you didn't account for some edge case in your client application, and the type system will help you, but so much. And for this purpose, the testing service should be fast and flexible. We talked about that. It should be very fast to start up and generate data, and it should be configurable to use the schema that we need in our application. Great. We'll be exploring how to build such a tool, looking into a Camel GraphQL server and into QCheck. Now, if you have not seen this before, if you go to events, and if you go to past events, actually, never mind. If you go to videos, you can actually see some of the past live streams here, and there have been live streams about this in particular. My internet is super slow. Do it. All right. 5 days ago, we were talking about GraphQL APIs. That's where we looked into a Camel GraphQL server, and 4 days ago, so the day after, we were looking into property-based testing with QCheck. Now, I encourage you to look at the videos here, but if you're interested in pasting them, however you feel like, or sharing them and so on, Twitch is not the best place to do that because the videos are sort of ephemeral. They go away after some time, which is why I have started, and I should have possibly had a link prepared for this. So I'm gonna go into Discord and I'm gonna, where is it? Somewhere here, look what I built. No. Yeah, here it is. I started a YouTube channel where I'm uploading some of these streams, so they're available for posterity, and you can also, find more information about each one of them there. And if you have any comments or questions, you can just drop them there, and they will live through posterity, or until the world collapses and YouTube is no longer there. Again, it's called reasonable coding. The branding is pretty much the same. I'm something I need to work on that at some point, but you'll see all of the videos that I published so far. The ordering is a little bit wonky, but if you want to take a look at the GraphQL one and the property-based testing one, then go ahead and do so. You should be able to run this too in 2x. There's a lot of figuring things out and reading things on screen that you might be able to do on your own faster. But yeah, if you feel like you need them, they are here. I don't really know how to search to find channels, but I guess that if you search in reasonable coding in YouTube, you should find this thing. I don't know why it says 1 subscriber and 3 videos, but anyways. Yes, and if you like it, of course, subscribe, so you'll be notified when I post more things. There will be other things than streams in the future, but let's take it one thing at a time, one step at a time. Cool. So we want to build a tool, and we want to build it from scratch, so let's begin from the beginning. Let's build a repository. Now we want to build a tool that essentially will let us do fuzzy testing through GraphQL. So I was thinking that we could call this FuzzQL. If you have any ideas, this would be a perfect time to pitch them in. Of course, we can also do like recent GraphQL testing server, and that should work fine, I guess. But I figured that giving it a name that's kind of catchy, and because you also have fuzzy graph algorithms and so on, so maybe FuzzQL works. I'll give it a minute and then we can get started. And we'll call this thing, what do we call it? What is it? And GraphQL testing tool. We can elaborate on this. I got one good for FuzzQL, no one else? All right. Remember that on the stream, and I'm gonna go here, you can just leave comments here on the right and I'll get to see them. You can ping me like this if you want me to catch my attention. Ping, self-ping. And then I'll just come back here and reply and we can have a conversation. This doesn't have to be one way. Elixir Lang. Yes, much beam love, absolutely. Loving the beam. I would love it even more if we had a proper spec so that we can have multiple implementations of it and so on. But thanks for joining. Okay, so I'm going to call it FuzzQL, just creating the repo here. There's nothing, it's empty, zeroed. So let's begin. Oops, that's the empty thing. And I have an empty terminal here. There's no magic going on. You'll see a few things going in and out as we go, but hopefully it won't be too big of a problem. So I'm gonna clone this thing, FuzzQL, and this is just an alias that will clone and take me there. So no magic. And I'm gonna open a few terminals. Why am I gonna open these terminals? It will be obvious in a second. In the terminal number 0 on the left is where I'll do the writing of the code. In terminal number 2 here, right, is where I'll do the building. There will be a build server running here that will tell us when something went wrong. And in the terminal number 1 on top right is where we will be running the code, running the executable that we produce. All right. So first things first. We can begin by just making the simplest thing that will run this, that will essentially generate the random value out of some sort of query. So let's scope it out. So scope, and we'll do 1, and this will be the first thing we do. And the first thing we do will be to generate a random value on a query. Now, a query doesn't have to be an HTTP or a GraphQL query sent over HTTP. We could also use this as an opportunity to redefine what we think of as a query. And a query could be any user issued command that we use to as an input, right, for generating a value. So it could be an HTTP query, right, like HTTP get, I don't know, query GraphQL, and then in here the query will look like this will be serialized differently, right? But it will be like our users, and then let's just get all of the users, and from all the users, let's get single person name. The person's first name. This could be an input, but also, right? We could simply just be have it be a CLI tool, right? So we call fuzzql, right? And then we say like, and this already outputs up like a list of names, like Leandro, that's my name, and then we have what is it called, ElixirLang, and then we have Xavier Villa, which is the other one. I probably should use my handle, so not to confuse anyone. So this could be something that we do. I think I'd rather use a GraphQL interface for it, so we feel closer to the domain and we don't accidentally drift away and build something that's completely different. So I would rather we set up a GraphQL API for this. Thankfully, I'm going to call this window FastQL. Thankfully, we already have in the past, in the stream for native GraphQL APIs, built a GraphQL API that responds to queries over HTTP and runs as an executable that we run natively, right? And that one is called MCU Reason MCU GraphQL Server. On this little GraphQL server, if I build it, oops, there's no rule for building. Okay, don't build, I guess, but don't watch. Has a binary, and the binary has an executable that we can run. Okay, and it runs over here, which means if we open graphical, then we can put it there. Just gonna make this bigger, and let me know if any of the fonts anywhere don't look nice. And I'm gonna query it, and then we get some people. Tony Stark from Manhattan, alter egos name Iron Man, Thor from Asgard, and this might, I don't know if that's the right way of writing it out. But anyways, we have this sample, this very simple GraphQL server, right? That the response works. I mean, you see the queries here are being parsed and executed and whatnot. And maybe we can use this as a base and just swap how we get the data out, or rather swap this fixed data out for randomly generated data. So then it will not be really random superheroes from the Marvel Cinematic Universe. It will rather just be random data. We can define random first names or use a dictionary and whatnot, but at least every time we run the query, we get different data, and it all still makes sense into in the context of our GraphQL schema. What do you say? Should we go this way? Should we try to make this server generate random data? I'm gonna get some water in the meantime. All right, I think it's a good idea. I don't see any opposition, so I'm gonna assume Swedish silent agreement, like in meetings. Nobody says no, so okay. And we'll essentially take some of this code. I don't know. I think it'll be easier than trying to bootstrap a new one from scratch. Like, for example, here we have the schema and the server, right? And the schema essentially defines the camel types, but it also defines the data that we're using. So as long as the types are available, right, separated Okay. Hopefully that answered your question, Xavier Villa. Now, answering Elixirlang, I think what we're looking for is not just a server that returns random data so that you get random strings. It's a server that you give it a GraphQL schema, right, that you're using already in your application, and it will generate random data that complies with that schema. So if you have a type in your schema called person, right, it will generate random people. So random values of type person. Doing something like random string length might be a shorter, a lower hanging fruit, but I see less value in that. I yet don't know if this is gonna end up well. It might be the case that we need to write a random generator for each one of each one of your types separately, and you can't just feed this tool the schema. But that's what I want to find out, right? Because if we can't do that, then we can build this one tool like FastQL and just make it really robust, make it very, very fast, so you can use it with any schema. You give it a schema, and because all the GraphQL schemas are defined as an AST here, and they are well typed in the sense that they will have a type that is a type in the GraphQL, in the camel type system, right? Then maybe we can build a general tool to solve this problem, which I would really like. And of course, if we publish it as an executable, you can npm install it if you want. Doesn't need to be used inside of an OCaml project at all. The only thing that we need is the GraphQL schema. But less talking and more doing. Let's see what we can do. All right. So I'm gonna essentially take all the code that we have here, right? I'm gonna copy all of the source, and then we're gonna start taking things apart and making it nicely. So let's go to FastQL over here, and then we move the source folder. That's good. And then I guess the next thing we want to do is we can also copy the Doom project and the opam file. We can rename them in a second. Cool, we are out of there. Great. So we decided that we're gonna generate a random value on a query, and our query is gonna be I'm gonna copy this query on the left here, right? GraphQL. This will be our query. So we'll do on query GraphQL. We should see random people generated. And actually, let's do a random person. We can start with one, and then we can generate more. So the results will be like JSON, I believe. Yes, and we can just copy this thing with a random person. Any ideas for the random person? Yes, no? I guess the name and the age and so on would be fairly strange. It'll be like first name, right? And then last name, and then we just do like, I don't know what the strings look like really. I'm gonna remove the white spaces. I think it looks nicer. And then bunch of semicolons, and lastly the alter ego will be there you go. Beautiful. If you need a fuzzy tester, just let me know, and I'll fuzzy all of your tests with my incredibly manual fuzzy testing skills. Cool. Let's move the opam file to have the right name, and now we can open the Doom project and just rename this thing to FastQL. Cool. And then we want to go into the opam file and change this thing into FastQL and all of this meta work. And GraphQL fuzzy testing server. Everything should be free and live. MIT license. You can use it however you want. FastQL and FastQL. Blah blah blah. Okay. So we're not gonna need Oh, we're gonna need some of these things. But I wonder if we can make some of this, swap it out later. Okay, let's begin here. We know that we have a tool that we can do and build, start building, and once we build, it should run just fine. So if I run the exact same tool, then of course this query will give us the exact same data. You can tell that the query is running here, and then we see the server doing its thing on the other end. So let's begin by taking this project apart. I'm gonna ignore, wait, 1 second. The build folder, so my fuzzy completer, there you go. Cool. So we have a few things. We have, 1 sec, it should be .merlin, there you go. Cool. We have a schema module, we have a server module, and we have a binary. The binary essentially just set up the logger and tells the server to start in a port and gives it a schema. So right now we're going to be working with a single schema, but the idea is that we can extract the schema and then load it from a file. So if we can start here with this schema, then we can swap it out and see if everything still works. Or we can swap it out and see if everything still works, and then we can change the schema and see if things work. Okay, so this doesn't do much. And then the server, and this is also a refresher for myself, the server is a little bit of a lower level handling of things, like getting a query and parsing it, and with the GraphQL parser and so on. This little bit we're not going to look into too much. It's essentially a very low level, well, let's say it's a lower level piece of code dealing with Unix sockets and buffers and so on that we don't really want to talk about right now. But if you're curious about how to use it, take a look at HTTP AF. And if you want a higher level API for that, I've been working in something called HTTP Kit. Oops. That essentially lets you write middleware style servers. Like if you worked with Connect or Koa in the past, it lets you write something like this. Start a server, use this middleware, use this other middleware, reply with this thing over here. And it has a small router that you can use as well. But yeah, I'll let you look this up by your own later. Let's go back to the thing. So we're gonna ignore the server since it's fairly generic. It doesn't make any assumptions on the schema that we're working with, and we can tell that because in the Dune file, you'll see that we have dependencies, but there are no dependencies that reference our schema. So we can swap this out later, it should be okay. Alright. So next thing that we have is our schema module. And our schema module depends on GraphQL, but doesn't depend on much more. And what does it do? It defines these types, and it defines the schema. Okay. And right now, oops, there's a little bit more. It defines what's an alter ego, superhero in the Marvel Cinematic Universe. It also defines what is a person in that same universe, and you see we have some fields like first name, last name, and whatnot with documentation. And then it defines a resolver for the query people. Now this might not be obvious, but queries are essentially another sort of object in GraphQL, and let me rephrase that. Queries are actually fields, right, in a special object called query. So just like we did, there would be an object called person, and we created this object person, and we said it will have some fields like first name and so on. And of course they have an associated function that will extract the value from somewhere. The queries at the top level are just fields on a schema. So we have people there, and this will just return a list of random people. So what we can do here is essentially try to generate something that has this type, right? And this type should be list of person. If we see, the type should be at the bottom left. So we need something that generates a list of people like this. Okay, let's see what we can do about it. We said we were going to work with a library for fuzzy testing, property-based testing. Well, sorry, they're not the same thing, but potato, tomato. And the one that I wanted to use originally is QCheck. And if we go into QCheck, Camel, right. It's a library built by Container Cube, Simon Cruans. Have a look at his work. It's actually quite impressive. And this library seems to have a module that lets us generate data based on a specification that we give it. So essentially here, right, we defined our type for a tree. I'm going to make this a little bit bigger, zooming in. And we define a generator for this type, for this tree type. So then we can call quick check generate n20, and this should generate a few trees for us. So there's a little bit of a hint on how we can do this, right? We could try to write the generator using quick check to have a look and see whether we can come up with these values on our own or not. And there might be some documentation around how to use things inside of this module. Some of it is obvious from here, right? Like we have generate and so on. Arbitrary tree. Sorry, I'm just going to read through the rest of the code sample. And it says, here we write a generator of random trees using the fix combinator. Fix's size is a function from int to a random generator. In particular, for size 0, it returns only leaves. Okay. So this seems to be returning what? The size combinator first generates a random size and then applies its arguments to the size. Other combinators include monadic abstraction, lifting functions, generation of lists, arrays, and a choice function. This is promising. There is a generation of lists. We might as well generate a single person. And actually, I think that's in our scope, right? Yeah, people, a single person. Okay, so we just need to generate a person of this type and an alter ego of this type. Cool. Then we define arbitrary tree, which is a QCheck arbitrary value. Okay. Interesting. So this has a way of printing a tree for testing purposes. And it has a way of shrinking the tree. And this means making the tree smaller. Why would you want that? In this case, let's say we generate 3 people, right? And some tests that we're running on some server fails. Now, we don't really know which one of this is the one that is actually failing, right? So what we can do is return you 2 of them. And if we hide, in this case, Gamora, then maybe you fail with Tony Stark or Thor. But if you fail again, then we still don't know which one you're failing on. So the shrinking will reduce the size of the test, the generated input, or rather, the generated output, so that you can more closely narrow down exactly what the problem is. In other words, it's trying to look for the minimum, failing test case. Good luck doing that manually for, some testing. Okay. Of course, the shrinkers are a function that we write, and they can have any strategy that we feel like. We don't really need to know this or here. Okay. And then it writes a test that makes use of this arbitrary tree. Okay, so it sounds like we can get away by essentially using the quick check gen module and generating a person from that. So let's see how that works out for us. So right now I'm gonna hack along and just put things in this package. This is definitely not where I'd like to have it. Q check, and then we're adding to a POM. Q check. There you go. And everything builds still fine. And what we want to do is we want to make a generator. So let's begin by making the superhero generator. And actually that we could easily do in a separate module and should be okay. Okay. No, we can't, because we have a dependency in this module and then there will be a circular dependency. Alright, we can just put these things in here. We can just say let superhero gen, oops, and this thing should be I guess something of type gen t. Let's take a look at what's inside of this module to see if we can find anything that, oops, could check. Ooh, that's a long function from 2 booleans. Gen, and then in here we have plenty of things. I'll expand this split so we can see everything. And there's a generator for lists. Okay. No, we don't need that right now. One of, a pair, a float, a record, pure, quad, return. Interesting. Generate. It's a function from a random state, an integer, and a generator that will give you a list of whatever that generator comes up with. And then it's generate 1. That generates just 1. And int range map numeral. Huh. I am a little bit lost, but we'll figure this out. So what can we use to generate a single record? If we go back to the example, this seems to have a function. Fix, let's see the signature fix. Okay, so fix takes a function from sized to sized. What is sized? Great. It takes a function from size A. Sorry, it's a function from size A to gen t. I wonder what is this? What is this self there? Because we're passing these functions to... okay, let's take a look at the signature of tree gen by looking at what generate expects. Because if fix doesn't fully apply this function, then we might actually have this n at the very end available here. Generate. And no, okay. So no, it doesn't seem to work the way I expected it to work. But this is going to be using all the generators to try to build for this record. Let me quickly search for record here, and I see nothing. Runners, long test, integrations. Let's open the docs, you know. Might as well go check the docs. For the last version should be okay. And we want to check the QCheck module. And I'm going to make this a little bigger. This library is here to ensure compatibility with versions from before. Qcheck 08, that's fine. I guess we wanted to check the core. Cool. I'm gonna search for record again. I don't see any of that. I'm gonna go into Genfix and let's see what the documentation for this is. Fixed point combinator for generating recursive size-bounded data types. The pass size parameter should decrease to ensure termination. Okay, cool. There's an example there. Okay, so I am thinking that maybe what we want to do is have a generator that will use other generators such as string to come up with the values and then put those inside of the record that we want. So we want to come up with something that will have the type gen, t, and then super here, right? So what values do fulfill this? There should be a value here. Return, for example, creates a constant generator. No, we don't want that. We want the generator that we can wait, what do you mean when you say a constant generator? That yeah, okay, so this will just take a value and return a generator that always returns that value. I guess that we want to have a size bound generator. I'm not sure. The size bound generator will mean that given some size, we can use that as an input for generating the properties of the person, the superhero in this case. And float, right. Huh. It's nice to explore all the combinators. We get a very good idea of what is already there. These pairs, triples, and quads are more useful than I'd like to admit, especially when you're doing arithmetic operations on some things. Option generator will generate an option of some type. Okay, but then we have a map. So I'm thinking the person may or may not be there. Okay, but in these functions we don't actually have access to the random state. Frequency shuffle A, small nat. String size, small string, join size. Unless we need to use... Okay, now here's an idea. What if we use quick check the gen, right? And we use string to generate the random string, right? And if we call this, then we actually have a generator for a string, not for this, for a superhero. So if I save, I expect to see a type error. Line 3. String actually just takes... it may take a character generator, but if you don't give it one, then it just has to state. It just returns you a string generator. And now, what we can do is we can map over this generator, right? with some function that essentially we get. If you look at mind, where is it? There you go. We can map each generated element, right, from a string to a superhero. So we could say name, and then this would be name. I'm not entirely sure why we get that type error in particular, line 4. And then, okay, I guess this is not a call. This should just be using the name. Should it though? I would expect it to be called. Okay, so what is the type of this thing? Now we got a t. Okay, it gives us a string back. Wait, why? Should be t of string, and when we call it, then it should be t of string. No, it should not be string. What's the type of name here? Character 20. Okay, I think I know what the problem was. Before we had this over there, and this happened. If you can read the code here, sorry, I was trying to pun the name of the argument with the value, and then what happened immediately afterwards was that the formatter just said, "Oh, you don't need the braces because you're clearly just using this value," and it removed them. So now this it's just this value that we have here, right? That comes from here and here was clearly not a superhero record. So I'm not entirely sure why it tried to unify these things as a string. But if we just use it, the generator instead of calling it, and then we wrap this properly, we actually build the value as we expect it to, then we have a superhero generator. Cool. And once we do this, I know that we probably want to try it out first, but because we need the person, we can just build a person generator. And here we could say that we will need 3 strings and an optional superhero gen. So here we can do triplet. Is it triplet? I forget. Yeah, triple. Triple string, right? And we will also need an optional superhero gen. By the way, I'm just assuming this is the way we need to write this thing, right? It'll come up as fairly obvious in a second whether what I just did makes sense or not. And we'll use the first name, so name, last name, hometown, and then alter ego. And we can build our record with that. We can just say first name. Actually, I'll do this. Last name, hometown, alter ego. And I saved, and it did not format, so we clearly have something wrong. And I think the problem is that we have an extra parenthesis. Where did that one come from? Okay. All right. We have a typo in the name of the type. So person there. Cool. So now we have something that is also broken. And I think this is because the first thing is a triplet, but the last element should be a second argument. If I say that, still same error. Okay, then I'll actually read the error now. It says on line 15, right? this expression has type t of a triple of strings, but an expression was expected to type Okay, so this is not working as I expected it. And I believe it's because of the operator that we're using immediately after. Opt should take a type, a generator relay, and it should give you something out. So if I do quick check, the gen, the opt superhero, gen, then this should be an optional superhero. Yes, that works. Now what did this one do? I think I'm using the right one, I don't know. So this is an infix operator for composing a function generator and an argument generator into a result chain. That's not what I thought it would do. So how do we? Essentially, I want a function that will given two generators come up with both values at the same time. And by that I don't mean like in parallel. It'll just come up with the values and then apply. I can map over them with both values being present. So I think I read something like join. No, that's not it. Collapsing, size fixed. We could use quad for this one in particular, and I guess you could always just nest these things together, like a pair of a triple and an option, right? I wonder if there is any other higher level way of doing this. Okay, if I can find one, then we'll go for that. Alright, whatever, let's do that. Let's do a pair where the first element is a triplet and the second element is an optional. So now this will be like this. So many parentheses. Oh my god. No, but that builds, and this is kind of cool because we now have a generator for a person that will rely on an automatically generated superhero, and it will come up with a first name, a last name, and hometown. So let's use this. Let's actually put it somewhere. Before we were returning, I went to the end of the file. Before we were returning, if you want to keep track of that, like what the hell am I on the screen, you can see the line number on the left, and this also is very useful for ballparking where you are in the file. This is the percentage of this line falls on, where the first line is 0 and the last one is 100%. So if you see 50% there, it's like, oh, it's probably the middle of the file, which looking at the left number wouldn't really tell you. Okay, so let's look how to use this thing. And we saw over here that there was a generate method, right? That took a number and a generator. And based on that generator, it generated something. So let's see what happens when we use that instead of this. So qcheck, generate. Oops. And we can do generate 1. And we can say this will just be a list of one generated person. So person generator, save. That worked. I am scared. I'm going to run this thing again and see if when we make a query, we get a single person with some random data in it. Okay, so 1, 2, 3, play. Nice. And we play again. Oh, that's a long name. And it has no hometown. But good. This is something that we could already start using for testing this particular API against clients, right? Normally, I would say using string would not really be convenient, right? It's just too big a blob of crap. crap that we don't need or want. However, we could come up with a, let's say, a smaller generator for a name. This, of course, will be very specific to. Yeah, I've heard that joke. But we can come up with a name type, right? That essentially will be a string, but we can only generate it in some ways. Or you could come up with a list of names and use qcheck the gen. I think is one of. Right, that takes a list of variables and a list of arrays, and then we could pick up random names that are kind of listed there. But that, of course, still biases your tests towards what you expect. So perhaps there is no ideal solution for this. A good enough one would be a dictionary that has, let's say, around 1 million names that come from different nationalities, and everything is more or less properly distributed. So that you don't end up having a massive amount of Spanish names or a massive amount of English or names or Asian names and so on. And then you can test your application much more nicely. Even better would be to be able to parameterize this by saying, hey, generate values that come from this place or that other place, like location or so on. Because sometimes we build web applications that are just not aimed at everybody, right? You build an internal tool for your law firm in Mexico, and then do you really need to internationalize it so that people in Japan will be able to use it? Maybe not. Maybe you just need it to be in Spanish. So that might make sense. So I'm starting to consider that not only the schema is necessary, also a way to override what the generation of values for these types in the schema should be. The data sources for the generation of values for the types in the schema should be. That might be something that we want to look into the future. Anyways, so far, right, I think we've reached our scope for the first one. We generate a random value on a query. We get the query, boom. We should see random person generated, and this is pretty cool. Now, what I would like to do is explore what would it take for us to come up with this random generator, right? Without having to manually write it in. Sure, it's not that much work, right? But you still have to be in this mindset of, using monadic combinators and the random state monad and making sure you have your right types in place and so on. And if you're writing your application in anything else, but you have a GraphQL service that gives you this data, maybe sitting down and writing all the types, it's a pain in the ass. It might actually be impossible to do the same thing. Maybe the camel type system is not permissive enough for you to do some things that you'll be able to do in JavaScript in your server that kind of match the way you've modeled your schema and so on. So we need to figure out what is possible here. Before we do that, right? Let's actually save this as a README MD, and I'm gonna turn this into scope during the live stream in reasonable coding. We will try to hit the following milestones. There you go. Generate random value in a query, and this will be done. Great. On query, this is the query, which is here random person generated, which we do see. Let me just add top there, FastQL, GraphQL, fuzzy testing tool. Cool. What should the second scope be? I believe the scope, there's just one scope. The second milestone should be to read the schema from a file. No, wait. Okay, let's take a look. I know that the GraphQL module that we have here, right, has a way of parsing a schema from string. Schema, and then maybe parse, read, no, GraphQL, parser, parse. Okay, let's look into the GraphQL schema module for anything that has a type that sort of goes from, I'm gonna put this up there, that sort of goes from a string into a GraphQL schema.t. Okay, help me out, look for things here. That's not that much. We're gonna go into the ones that have v, those are values, right? And then we'll look for int, scalar, string. This seem to be just things we can use to build a schema. There's an IO module that you can bind. It's okay. It's a stream module, definitely not what we're looking for. Huh. Interesting. I am not entirely sure how to grab this string and turn it into a GraphQL schema. You know what? Let's look at the repo and see what it has. Camel GraphQL server. So you can define the schema in code. Only valid schema should pass type checker. If the schema compiles, the following holds. Okay, examples. Not very promising. This will definitely work, but it's defining the schema through the library rather than, hey, I have the schema somewhere, I need to load it up. There's a parser. I do not know if the parser can actually parse the schema definition language. Failed inline. These are all the types for the parser. Oops, sorry. Same file. Yeah, Armstrong. Nice. Huh, okay. Let's look at the tests and see if there's any tests here. There is some. Escape string GraphQL. Okay, so this is just queries that we're making. Introspection. Again, a query that we make. Kitchen sink. All right, I'm gonna assume, because I don't see any test cases that parse the schema definition language, that there actually isn't support for this just yet. Might be that there shouldn't be support for it. I do not know. API. Ooh, this is pretty old, but it's just an index, so it should be okay. Let's search the issues. Schema definition closed. Schema types. What if I throw language in there? Do we have anything? No, we have nothing. Okay. Oh, this is so cool. GraphQL WebSockets. I mean, you have subscriptions, right? Nice, very very nice. Clearly, this is a tool. It's being put. There's time being put on it to make it amazing. It just happens not to support one thing that we would have needed for this. So it looks like to actually do this, to actually read the file and come up with a schema, because the schema requires you to, if you look at most of them, like, where is it? Enum and field and so on, they require you to either provide a type or will infer a type that matches a type in the OCaml type system. It seems that we will have to do something that essentially, I'm gonna just sketch up here some lines. Reads a file, parses that file into an ASD, right? And then it should generate OCaml types that match that ASD, and then it should generate the GraphQL schema, and this is from the library, from the lib, right? That matches the ASD. I'm gonna put this names and numbers here, so it's easier to reference them. From 2. So now you have the types, right? And then you have the schema that matches this ASD from 2 and also uses these types. And then you would have to generate, lo and behold, generators for those reason/OCaml types. This part is trivial. Parsing that file into an ASD will require, and this will, let's say, we'll need to write GraphQL schema definition language parser, hopefully with Angstrom. And then once we have that, we'll be able to parse the schema into an ASD, into a data structure we can work with, and then we would have to write down the types from somewhere, right? And for this, I think we could use type tree, the OCaml type tree library to generate the code. I don't know if it will be ideal, but it's just a thought that I'm having. And we could use the same thing here to write these types. I'm just going to duplicate that. And yeah, we will need to write this code. I think something like this will make sense. once you have the AST, then you have all the information in the GraphQL schema that someone put you in a file. Then you just need to generate the types from a camel. In fact, you can do this like 5 and 4 in any order, right? But once you have the types from a camel, you can just write the generators or the schema. The interesting bit is that this part over here, right, is essentially a tool that takes like schema.graphql file and returns you a native GraphQL API, or I mean minus the HTTP or the transport, which is it's interesting to think about. I'm not sure how much work it will take, but it will definitely take some work. I'm gonna write some notes here, notes and doodles. What would it take to read the GraphQL file and generate the rest? Now, there's another library that does something similar. There is a library that it's actually a PPX that takes a schema.graphql file and lets you write type-safe GraphQL queries. And it's meant for working with clients, right? It's GraphQL. Oops, let me open the tab. GraphQL PPX by Magnus Hallin. And the way you use it is that it's actually meant to be used with BuckleScript, right? But the way you use it is that you enable the PPX flags by passing in the PPX there, and then it will automatically read the server schema. But you can pass in your own server schema as JSON. And the reason it's JSON is that the introspection query returns you JSON. So, for example, in our server over here, when we run GraphQL against it, GraphQL automatically sends this introspection query on boot time, so that it has access to all of the schema definition here, like people returns a non-empty list, a non-null list of non-null person values. And in here we have all the fields documented as per our schema. But this query is a query that we can make ourselves, right? And it returns some data back. So if we quickly go into the test cases that we had here, we actually had, where is it? Examples, no. I forget where it was. Right, parser. Data, test, introspection query. You can just send this query here, and we'll see that we get a data structure back that describes our okay, interesting. So we don't really need a parser for the schema. If we get this, then we can just use a standard JSON tooling to work with it. So read a file, and we don't need that anymore. If the file is the introspection query, is the schema dump as JSON, we can use we don't need a parser. We don't need to write a parser, at least. Okay. And then in here we should have enough information to write this, really. So I'm gonna take this schema that we have here, right, and I'm gonna save it as a file in the repo. Schema.json. There we go. Saved. So the ideal syntax will be something like this, right? And then you run it, and then you have the server. Read GraphQL schema dump from file. Okay, this one actually is not going to help us. And it's not going to help us because reading the schema from file is not going to build up the GraphQL schema for us. And even if we do build a GraphQL schema from it by traversing over the JSON structure and trying to map it into GraphQL schema objects with fields and whatnot, which should be straightforward. I believe there is at least a one-way arrow from the GraphQL schemas in one side to the dump, so I believe that you should be able to take the dump and go back into the schema. I may be mistaken. I have been mistaken before. But this will not explain, this will not help us in coming up with types. And the reason is that Camel and Reason do not let you create new types on the fly. You need to define your types during compilation stages, which could be either writing them down in a file manually, or could be having a program that will generate more types based on some annotation that you have by writing them down for you. But essentially, all of the types should be written already. So the interesting question is, what is this doing, right, to generate the types that it needs? Limitations. I'm gonna need a second to get some more water. I will be right back. And I am back. Alright. So if this is doing any... There's an ASD out flag. If this is doing any type checking, then it should be creating some type somewhere. That's my belief. I may be wrong. So there's a base library here. And I see some pre-processing, data checker doing oops, sorry. Rule no units variables, rule known argument names, schema ML. Is there any interface file that we can look at? Multi-visitor. Right. The lecture parser. I wonder when the entry point for this module is. GraphQL PPX space. Okay. There's a PPX config. Maybe that's the entry point of the PPX. Nope. Doesn't look like it. Read schema. Okay. Let's go out a little bit. Source. For native. We can use this natively, okay. Alright, so here is where things begin. You take a driver and register a transformation with the following extension, that's the name over here. It's a model expression, ASD pattern. Not entirely sure what this is. It's a value somewhere, but I don't know what it means. And rewrite is the function we'll call whenever we find that. So if you find when matching, right? Okay. Right. So it's trying to match on a query. So constant expression of type string, and then it has a query, and then the delimiters, I believe would be these ones maybe. And it calls rewrite query, which takes the line of code, which comes from running this. We don't really care about those right now. And then the delimiter, and then the query. And then it begins the lecture through GraphQL lecture with the query. And then it consumes lexemes from it. So if things are good every time you consume, I expect this to recurse at some point. No, okay, no. Never mind. This will just consume the whole of the lecture. So you build the lecture with some query and then you have to run it essentially. And then what you get back is a bunch of tokens that you can use to create a parser. And then you try to parse the document with a parser. And if it works, then you get a document. Okay. And then it runs the validations, and if everything is good, then this if all the validations are good, then it calls result decoder and unified document schema to get the parts out. Generate modules. Okay, so this is a little bit what we would be looking into, right? If we were to read this thing, then we would like to generate some modules that will have some of this code. And it looks like we might not be able to do this in runtime. It looks like this would be a compile time thing to do, which kind of sucks. So I really wanted to be able to just feed it any in the schema and get any of the any server up. But it could be worse. It could be impossible, or with the tools that we have. So let's look at generated modules and see what that feels like. Oops. That's right. Output native module. Generate modules takes all the operations, and for each operation configuration it just runs the operation. So for a default operation it will use the default operation. Okay. I don't know what mod.mk is, but it sounds like it's making a module, and then you give it parse tree module structure. I think this is from parse tree. I don't know. Yeah, parse tree. Okay, that makes sense. Alright, and then we want to run this thing, which is this function over here with some variables. If we look for that function over there, then this just takes a bunch of variables. Input values, and then it creates a decoder, and then it creates a decoder with the configuration and the result structure. Okay, I would say that what we would like to do here, right, is by here I don't mean this piece of code, but I mean this particular stream is not entirely doable in this particular stream. It might not be entirely doable at all with the OCaml tooling we have right now. It might be that we need to do some other things, and that you can't just pass in the schema to the server for it to be able to do everything. It might be that this tool needs to pack an OCaml compiler, right, to be able to generate code and then compile that code and then run that code as well as part of itself, which is an interesting thought to have. But at the very least, we have looked into how we can, given an already existing OCaml GraphQL server, how we can write a test server for it. And in this particular case, it just involved writing a few generators like we saw above. Where we have some types and we write the generators for those types. And of course, we don't need to necessarily use this for GraphQL purposes. We can also use this generator for running tests on logic, in case that we're using these types as well somewhere else. But it's very interesting to see that it's not too convoluted. I think it's fairly simple, which doesn't mean that it's easy, right? Each one of these things do just one thing, which is a very they're very constrained functions, these combinators. And then, of course, it takes some time. It's not fairly easy to put them together at first. But once you understand it, by the Clojure definition of simple, then they also become easy. But that will take some time. All right, I think we can't do much more right now. So I think that what I'm gonna do is I'm gonna keep looking into this. No, you know what? What I'm really gonna do is I'm gonna end the stream, and I'm gonna talk to some people. I'm gonna talk to Malin, Magnus Hallin here, and also to Andreas from, where is it? I lost it. Camel GraphQL server. To see if they have some ideas of how we can make this happen. And it might be the case that we can, and it's fairly straightforward to do, and I'm just not saying it. I am 100% not an expert in OCaml. I just know enough to learn more on my own. Which I think is, alright. Like it doesn't sound that much. But other than that, I'll return to working to the Twitch board CLI tool, which is a tool that I'm writing to be able to get all of these things that you see here on the stream, like the comments and the stats, like how many people are watching and so on in the CLI. Because let's be honest, who here wants to stream this thing, right? And have a phone on the side always open, checking for comments and whatnot. It's fairly annoying. It would be much easier for me to have everything in the same place. It would also make it easier for people watching this on YouTube later to see what I answer to, because I don't necessarily always read out the questions or comments that you have, right? Which is sort of annoying, I guess, for some people. Yeah, so I think that's what I'm gonna do. I'm gonna close the stream now, and I may open a new one where I'll be working on that, but that's, outside of the scope of the event. So recapping, I'm gonna add all of this. Yes, as an initial commit to the repo. I think we already had an initial commit though. No, okay, so we can do git ponfu. Boom. Recapping, we wanted to build testing server. We didn't quite get to building a testing, no, we wanted to build a GraphQL fuzzy testing tool, sort of. We couldn't do that, right, in the scope, in the time that we have allocated for this. But we found out that on the first milestone of this scope, we can build GraphQL test servers, and it's fairly straightforward. If you depend on a library like QuickCheck, then you can just generate generators for your types, and then the only thing that you would need to do is to swap out the types on your schema, right? So in any query where you're doing the resolution of this data, and I guess we can just, in any query where you're doing side effects and fetching things from database, you can just replace that by a call to qcheck gen, and then generate as many as you need, 1, 2, or n, or none, right? And that will help you build data that complies with your schema. It's completely type safe, right? Complies with all of your schema, and you can use for testing purposes, which I think is pretty cool. I actually will come back with these learnings to work and try to build something that we can use internally as well for it. Unfortunately, it won't be in OCaml or Reason, but I think having a tool like FuzzQL, even if it's not a tool that you call on the outside, even if it's a tool that perhaps you that lets you build an executable emulator for your specific service, right? Like you put it as a pre-processing step, and it will generate this emulator module. Then that it's a binary on its own, and then you can use your MCU GraphQL. Let's say MCU GraphQL is your library emulator. Then that would be good to have. Even if it's not like, oh, FuzzQL, and then here's my schema.json, but maybe it's more of a development time tool that you include, and then you generate an emulator automatically. Yeah, so we've gone through what it would take to read the GraphQL file and generate the rest. And we found out that it's some things that we need to look into. There's not much for me to do here other than sending questions and reading a lot of code from other people that might not be ideal to do with all of you watching. Anyways, if you like this, the repo, of course, it's in FastQL. I think docs rephrase. FastQL over here. Oops, here. You can have a look, fork, and play around with it if so you feel. The libraries we've used for this have been QuickCheck by ContainerCube. There are other libraries that we can use for this. He himself recommended me one called Random Generator by Gosh. But this library is a little bit old, which does not mean that it's not good or feature complete or whatnot. It could just be stable. It needs some updating of the build system and some small things, but other than that, it looks very good. And we've looked into a Camel GraphQL server lightly and seen how we can plug in the generators in it. And we've looked a little bit about into what GraphQL PPX is doing to provide type checking through a schema.json module. Sorry, file. All right. If you liked any of this, leave a follow here. If you want to go into the YouTube channel, then you can just always just YouTube reasonable coding. You can search for it, and it should be available. The stream will be up there later today. If you like it, subscribe, leave a comment, and whatnot. Anyways, this is it for now. I'm going to go into the preview. This has been Reasonable Coding for Nintendo 64. I hope you liked it. And I'll see you later. Stay reasonable.